Anurup Joseph. I'm, as Paul said, an independent consultant. I've been in the industry for a little bit. I've been coding professionally, as he said, since '94, and primarily focused in Java, kind of near the birth of the language, really. So since '96, '97, coding professionally in Java since '97, and enterprise Java since '99. I've worked in different parts of the country, as he said. Midwest is where I went to high school and college. We worked for Motorola in Chicago in the telecom sector for a little while, then came out to Silicon Valley in the .com boom because, hey, California, right? If anybody has experienced Chicago weather, you'll see why I made the move. And I was at HP for a good decade up in Silicon Valley, and then came down to LA for Sony for 5 years, so in the entertainment industry for PlayStation Network for about half a decade there. And then most recently decided to switch into consulting, so I was up in the Bay Area for a little bit. And in terms of other activities, I love traveling. So last year I only worked about, say, 5-6 months and spent the rest of the year traveling. Visited 10 countries last year. Overall, that's just my passion in terms of technology and also exploring the world. So been to about 35 of the US states and about 42 countries on 6 continents. And my goal is to visit another country every few months if I can do it. And that's what I'm really passionate about. Another thing that I'm really interested in is just learning new things and sharing things with others if it's hopefully valuable. And this talk that I'm going to give you is it's not really talking about cutting edge, latest and greatest technologies. It's not talking about the latest cool gee whiz gizmo or anything like that. Instead, it's a talk about how we can put together existing tool sets and use new means of using them, leverage these tools, and change our processes to make ourselves better, to improve our development process, and to help our teams achieve, hopefully, continuous improvement. And the technique I'm going to go over is called continuous integration. Now, this talk I gave to the LA Java Users Group a little while ago. It's the same presentation I gave, some variations to companies that I worked at, like Sony and HP as well. So hopefully it'll work out this way. This presentation is going to be going over a little bit of theory and some slides, and then I'll be giving a live demo, which is going to be a little truncated because to show a full thing would take too long. So I've kind of got a compressed demo to hopefully give you. And hopefully the demo gods will smile upon me and nothing will break in the middle of a live demo, so always that risk there. Okay, so again, just we talked about what I've been doing. What I'd like to know is a little bit about you guys, because if everybody here is already practicing all these things that I was talking about, maybe it's not so relevant and I can skip over some things. But so just wanted to know, are folks here, who here is using, say, waterfall development methodologies? Anybody? Okay, so we still have 3 folks or so using that. How about Agile methodologies? Anybody using Agile? Okay, all right. And for that was, I'd say, about maybe 2 to 3 times as many people. How about other? I think there were a lot of people who didn't hold up their hands. So other. People are shaking their heads. Okay. So does that other, by that, do we mean like no process or something completely different? Right? Is it like just ad hoc? And that's totally fair to say, because a lot of times when people are just getting started, there really is no process. It's just all ad hoc. And then over time, we try to institutionalize a process to be able to learn from our mistakes, prevent future mistakes, and hopefully create a more repeatable learning organization, right? So anyone heard of continuous integration before? Continuous delivery? Okay. Who here is practicing continuous integration? Okay, all right, good. So I think this could be helpful then. And anybody have heard of continuous improvement? Hopefully. Oh, okay, so 3 people, 4 people have heard about continuous improvement. In terms of process, do you guys have a process institutionalized of how you actually do continuous improvement, or is it just mainly, hey, just once in a while we can do it? Anybody? Process? What's your process out of curiosity? Is it like an institutional thing?
I guess it's kind of part of like our Agile methodology. So at the end of every sprint, we discuss things we did well, things we could improve upon.
Okay.
I don't know if that's exactly what you're talking about.
No, that's definitely great. That's part of like a sprint. Yeah, retrospective, what went well that we want to continue, what didn't go well that we want to fix. So that's good. Okay. All right. Anybody else here to show? Thank you. All right, so this is good. This is good. Then I was worried that this might be old news to everybody because it's my first presentation to the San Diego Jug, but it sounds like this might be useful then. So what I'll be covering is the process of achieving continuous integration through using continuous improvement through using continuous integration, and then institutionalizing a process to make this not episodic but repeatable, and ultimately achieving a goal of becoming a learning organization, an improving organization. Right? So sounds pretty interesting, but the fundamental word I'd like you guys to remember is Kaizen. It's a Japanese word. Right? I used to work for Sony. It's a Japanese word, and anybody who's either worked for a Japanese company has heard of Toyota or anything like that, Toyota Production System or lean manufacturing. It's a word that means essentially change for the better, or a synonym is continuous improvement. Now, if you folks have heard, Toyota was legendary in the auto industry for being the most efficient automaker with the least waste and with the least inventory, with the fewest defects, and people wondering how did you do it? And they really talked about Kaizen. I mean, tons of stories. You can Google Toyota Production System and you'll see them. One story I love is that Toyota engineers would take an assembly line that makes, let's say for the sake of argument, X number of cars. Let's say it's 10 cars per hour. Toyota engineers would take that assembly line that takes 10 cars per hour, and they'd say, okay, now make 50 cars an hour. Okay, well, you can try. Obviously, something will break. There'll be some point of failure, right? And then something will break, and then they'll stop the assembly line. They'll go find whatever it was that broke, right? Figure out what the fragility was. Did it not have enough people? Did it not have enough room for the sheer volume? Was the machine just not fast enough? What was it that broke? And then let's improve it. Okay. Then they'd step back after improving it and say, all right, you were making 10 cars an hour, let's make 50. Now they're able to make 15, and then the assembly line breaks. They say, okay, what broke this time? Oh, okay, let's investigate. Let's fix that, and then go on. So in that fashion, they were implementing Kaizen. They were continuously improving their process as a regular part of their development. As a regular part of their development, they were employing continuous improvement so that over time, with each iteration, they were evolving to be a continuously learning organization and to deliver better performance and better quality over time. So this techniques really inspired TPS, the Toyota Production System. And the software world got into that as well, because if any of you have heard of lean software development, LSD, that has essentially the Toyota Production System taken from manufacturing parts, physical things, to essentially creating software. And so that's really what lean software development is. If anybody's really curious, I have some appendix slides that goes into TPS in more detail, LSD in more detail, just overall Agile in more detail. Now, since there were actually, most of you did not say that you were doing, or a lot of you said you were not doing Agile development. I just want to briefly touch on it. Now, waterfall development, which is what I was used to when I first started in industry, is the whole idea of these people on high, these experts come up with grand requirements documents, and that conforms into eventual architecture documents and design documents and interface control documents and clear requirements that lead to absolutely beautiful test cases, and you follow this wonderful waterfall V design and you implement the code, and then you follow the requirements that map to test cases, and you meet all that and deliver code at the end of, say, 6-9 months, maybe a year, and it works perfectly every single time. In theory, I have never in my life seen it work that way in real life. Why? Because in real life, oftentimes, customers do not know exactly what they want. They might have an idea, but they're not really sure. And so it's all hazy in their mind. And if they could only have like a prototype or something in front of them, then they could say, oh, I like this, but I don't like this. And wouldn't it be great if they didn't have to do that 1 year, 1 year later, but a lot shorter? In fact, maybe we don't know all the requirements ahead of time. Maybe we haven't considered a huge chunk of requirements, like security, for example, or performance, for example. We haven't considered usability or upgradability, right? Maybe we haven't actually conducted user testing, so it works great for engineers, but it's a really terrible experience for non-engineer, non-technical users of our products, right? And maybe it just might be changes over time. Like, the business thought it was going to do X, but later was going to do Y, and we just need to incorporate that. So in the real world, change is a constant. Sounds oxymoronic, but it's true. Change is constant. We don't know really ahead of time what all the final requirements and necessities of a project are. So Agile essentially has a concept of being responsive, of being able to deliver software incrementally by breaking down functionality into a set of user stories, describing the user journey of a user going through interacting with our software that we're delivering. And by breaking down the stories into manageable chunks, we deliver a small piece of functionality over time. As an example, we're making a website. Okay, what's something that we want to do? Let's have a homepage story that when the user enters this URL, they see a homepage that contains a header with a company logo and a company vision statement, contains some contact information on the footer, maybe has a menu bar on the left, and so on, right? And it doesn't have to be fully fleshed out, but we can deliver that maybe fairly quickly and get the feedback from our users. Is this what you were talking about? And they'll say, oh no, completely different. Well, great, we found out early as opposed to maybe after 4 months, 5 months worth of work, right? That's the concept of Agile. We deliver functionality, we involve our business people, the customer, who actually defines the job well done. We include the customers in our process as early as possible, demo it to them, get their approval as we continue to deliver incrementally more functionality. That process yields much more flexible results, makes us much faster to respond to changes. In fact, we welcome changes because almost every couple of weeks or however long of our incremental unit that we do, sprint, iteration, whatever we do, we take new stories and new functionality, and so we welcome new changes and so on. So that's why Agile really responds well to real-world changes. And so there are different styles. You might have heard of Kanban, you might have heard of Scrum, you might have heard of Lean software. I'm not going to go into details about each of them. I'm just telling you why Agile seems to be getting more and more usage in the industry. So a lot of that, again, for my talk, lets us do Kaizen, or continuous improvement. Now, why is that important? Why is it important to continuously improve? Why can't we just stay static? Well, if we look around, the landscape is littered with companies and projects and teams that were just good enough. You're good enough now, but you know what? Our industry changes. Technology changes every industry, none more so than technology itself. And the tech industry is littered with the giants of yesteryear brought down. If you think about it, Nokia, when I was working at Motorola, was an absolute giant. They were the mobile phone king, right? They absolutely owned the market. The iPhone was introduced in 2007. Nokia, the cell phone maker, eventually bought by Microsoft, eventually the entire value written down to zero, and no longer exists really as but a ghost of itself in the cell phone market. And that was, again, the iPhone was introduced in 2007. So less than a decade, the giant, the #1 player in their field, the dominant market share, effectively is vaporized, right? Now that's an extreme example, but I just wanted to show that or illustrate that, to have that illustrate my point, which is continuous improvement is a necessity. We have to every day, every moment be improving. Why? Because our competitors are. They're not staying still, right? Think of this as a sports team. All our competitors are working, are practicing, are improving their processes, are examining their own systems to get better. If we don't, we will by definition fall behind. So it's an important thing for a competitive advantage. Also, we understand the concepts of things like tech debt. We always have to do shortcuts, right? We always have to make do with less than ideal solutions simply because we have to implement an emergency fix, or the business says, okay, it's going to take you 3 days, but that's okay. We only have 2 days, so make whatever compromises are necessary to get it done in 2 days. I don't know if you've had to do that. I've had to do that. And that builds up what's called tech debt, essentially suboptimal processes, suboptimal things that we had to code that we just had to get done for a business requirement. But over time, we would love to address that when we got the chance. And oftentimes, even when we get the chance, we sometimes don't do it. Why? Because we've forgotten, right? Oh, I wrote a to-do, but if I don't go back to that class file, or if I don't go back to that piece of code for 6 months or a year, I won't remember that to-do. That to-do now becomes part of the historical literature that was the software, right? So that's often difficult, but we need to do that. We need to learn tech debt. We also need to educate ourselves as developers because there are always new issues being discovered, new bugs being found with code that we're using or libraries that we're using or even processes or practices that we're using. There are always new vulnerabilities that we need to be aware of, that we need to constantly fix and patch. We need to identify any new issues that we create. In other words, even if our code is pristine and perfect, but I or one person on my team checks in a bug, or checks in something that is less than optimal or creates a new issue, we'd ideally want to fix it right away, right? All research on software development has shown that the faster you fix a bug, the less costly it is in terms of time and money. So the longer you wait to fix something, the longer you wait to fix an issue or to address an issue, the more costly it is. Over time, this leads to your team getting better, your team getting stronger, your team learning of these issues, and eventually it will yield competitive advantages. The teams that are most able to learn, most able to improve continuously, become competitively stronger and become the ones that are leaving the others in the dust. They're the survivors that go on. Hopefully, we all will be that as well. Now, what is the importance of continuous integration, right? Remember, continuous improvement via continuous integration. What's the importance of continuous integration? Well, the reality is any non-critical software consists of discrete pieces of functionality. Like somebody might be writing a UI, somebody else might be writing a database component, somebody might be writing a business logic, somebody might be writing some sort of application layer sorting system or searching engine or something. There's all kinds of things for different software that all are done in different components. And oftentimes, these different components are built by different teams of people, perhaps in different locations around the company or maybe even around the world. And so integrating those different pieces of software is important. And I share with you a personal story. Back in, I think, about 98, I was working as a build master for my team at Motorola. Back then, the technology and the processes of that time were really, we would laugh. I mean, I know I do when I look back at it, because the process at that time was, when we got back from lunch, 1:30 on a Friday afternoon, I'd email the team, all right, everybody, check in all your code, right? We're gonna do a massive build of everything, and everybody knew that Friday afternoon would suck because everything would break. Nobody's code would integrate well with other people's code. You'd always have some sort of bugs, and they hated me because everybody would have to stay late on a Friday night to fix the issues that we discovered. So anyway, that was what we would call today episodic integration. It was good for the time, but fortunately industry and best practices have moved on to the idea of continuous integration. That we have disparate software components, let's integrate them continuously, not episodically, but every single time with each check-in, right? So these components are integrated, these integration points which cause issues, let's not wait a week. Let's find out right away. If my coworker, my colleague just checked in something, let me get the latest code, or I check in the latest code and he gets the latest code, or she gets the latest code, and let's find out right away that something's broken, because as we've seen, the longer it takes to find an issue, the more expensive it is, right? So that helps us discover issues early, and as we saw, early means less cost, less time, less money. All right, now that sounds ideal. I painted a great story for you, right? The question is, how do we do that? How do we actually make possible this vision? How do we make possible this techniques? So what I'm going to describe to you is something that I first learned back in 2007, 2008 by actually the creator of Jenkins. It was called Hudson at the time. His name was Kosuke Kawaguchi. He worked for Sun Microsystems at the time, and I had attended the Java 1 conference where he was presenting, and it blew me away. It was really awesome. I loved it. I spent, like lots of long nights and weekends for several months implementing it at work, and presented it to my manager, and he really liked it. I'll tell you the story later in the project, or the presentation. And got approval. We implemented that at HP, and that became kind of the standard for many software teams at HP. The HP Agile Special Interest Group recorded the presentation I gave as a kind of a good practice that they wanted to encourage for other Agile teams at HP. And I moved to Sony. Same thing. We implemented the same sort of technologies and processes that I'm talking about here. And the Sony PlayStation Network is kind of cool. I was really happy to see that they've taken the practices that I've described and enumerated, and so they're actually making use of that. So at least a few companies are using this, and from what I'm seeing, more and more, it's getting more and more popular in industry. And so the vision that I laid out is actually achievable, and let's describe how it's being done. So let's talk about the issues in code, right? There are issues that could happen with already existing code, because let's face it, most of the time, none of us are working with greenfield projects. We're almost always working with code that has already existed but needs to be bug fixed or patched or have new functionality bolted onto it, right? So that means when we're coming into code that is legacy, that may have issues, and let's be honest, probably does have issues, right? It probably could be improved. How do we identify these issues? Well, we could manually review all the existing code. But remember, code does not remain static. People are always, adding in new functionality. As part of our job, we're coding. Every day we're adding new code, we're adding new functionality, we're changing existing functionality. So we could do it manually. We could get the team together, everybody inspect every single piece of code, and hopefully on the team we have the different and disparate experience of different technologies, of different business software layers, of the different libraries, of all the different best practices in terms of security, performance, scalability, right? Hopefully we have that on the team, all there to review every single line of every single piece of code. Hopefully we have that. Hopefully we have that expertise. But once we're done, then we get to repeat it with every single time we make a change every day. And let's be honest, that's slow. Humans get bored over time. I'm certainly not as productive at 7 p.m. as I was maybe, like 11 a.m. or 10 a.m., right? So humans get sloppy sometimes. It's human nature. We make mistakes when it's repetitive work. We're not good at repetitive work. We're good at creative work, but we're not too good at repetitive work. And especially if you have distributed teams, which more and more of us are having, as we have colleagues who are in different parts of the country, in different parts of the world. Every single project I've been on for at least the past decade and a half, we've had teammates literally around the world. How do you get everybody together? Even if they were in the same time zone, it's problematic getting everybody together in the same virtual room, even with video conferencing, to be able to look at the same code and such, right? So it's really difficult with distributed teams. And let's be also blunt. I don't know about you, but my salary's increased over time. I'm sure your salaries have increased over time. That's just a common thing. Our human cost gets more expensive over time. The time per hour, the cost per hour of a human being, of an experienced developer, gets more expensive over time. So this process, even if it worked on one day, it would quickly break down by the second day and would very quickly become completely impractical and cost prohibitive very, very quickly. So what's the solution? Fortunately, there exist tools that can do code review for us. Those tools are called static analyzers, and you might have heard me mention that earlier. Static analyzers are tools, are software tools that examine code without actually executing the code. That's why they're called static analyzers. They're not examining running code. They're not profiling running code. They're examining static code, static classes, to inspect the classes for issues. Why are they useful? Static analyzers are great because, as I said before, it would be wonderful if you had one person on your team, or if the entire team had a perfect mix of database expertise, web server performance, sorting performance, big O notation. If people had different levels of expertise in all sorts of issues, and if they all brought those issues to bear, it would be wonderful. But very often that's not the case. In fact, I'd say it's almost never the case. Ideally, that would be wonderful, but it's often not the case. And even if someone was an expert in their particular field, guess what? Your field continues to change. We always said that, right? Technology changes all fields, especially technology. So, expertise rapidly becomes stale. So, the expertise is necessary, it needs to change. Automated tools, though, are constantly updated, right? Software tools that analyze code are being updated so that we can, as new vulnerabilities are introduced, or new vulnerabilities are discovered, as new issues are discovered, as people find new bugs that weren't found before, they can be added to these analyzers. So these analyzers are constantly getting better at finding issues. Now these static analyzer software tools that I'm going to be talking about, they come in many different flavors. Some are command line, meaning you run them in the command line, you type a particular command, you give it a class file or a directory, and it goes through and generates a report for you. Some of them are, they wrap that by putting it in as a plugin for your IDE. Like for Eclipse or IntelliJ, they come with plugins for various tools, which are really nice because you can just right-click on a particular folder or your entire project and say, hey, analyze my project, show me all the issues. And then right in the IDE, you can click on it and you can go into the code and see the issues. And that's great. That's a wonderful thing because it's regularly updated, as I said, with new issues as they occur. Unlike a human, right? Machines excel at repetitive, boring work. They love that. Let a machine do that. Machines love that sort of work. Your computer's begging you to please give it this sort of work because they don't get bored. They don't get sloppy, right? And the issue, though, is that we have to remember to run this command line tool. We have to remember to run the tool within our IDE, right? And guess what that means? That means it's not continuous. It's episodic. It's whenever I remember to do it. You know, maybe if I'm lucky, I remember to do it once a day, maybe, right? But it doesn't happen with every check-in, and sometimes when I just don't have time, I forget to run it. Or even if it gets identified, we lose track of it over time because, you know, if I forget to deal with those issues, no one will. So this is episodic reporting, right? And so with the caveat that no tool is as good as a human inspector, this is at least better than manual inspection, which, as we said, is eventually impractical and cost prohibitive, right? But one thing to take away from this, we said human time gets more expensive over time, right? The time for a human, or the cost per hour of a human, gets more expensive with each passing year. The great thing about technology is the cost per hour of a machine gets cheaper with each passing year. So repetitive work like this is prime candidate for automation, for tooling and automation. So instead of using these tools manually, instead of kicking them off manually, the command line or via IDE, let's see if we can automate them, right? What if we make these tools automatic? And that's the proposal that I'm bringing, right? The idea is we will automate the static analysis of our code. Rather than running them at the command line, running them within our IDE, we will automate them. We will integrate them. And what's a good way to integrate? Well, we already talked about it. Continuous integration. This is like the prime example, the perfect recipe for our use case, our business case. So what are we saying here? Specifically, we're saying that we set up a continuous integration server such that each check-in, hopefully we're all using source control, right? Each check-in to our source code repository will trigger a build, right? And bear in mind, I'm describing an ideal case, right? You will have to adjust it for the size of your project and the size of your hardware. If you only can run this on very low-end hardware, maybe you can't afford to run it every check-in. Maybe it's just too slow, right? Or maybe you can't afford to do all the checks that I'm going to describe simply because your code base is so big and it just takes too darn long to do the analysis that I'm talking about. Again, your mileage may vary, right? But ideally, we integrate it with our continuous integration server, so each check-in checks out your code, builds your code, builds your tests, runs your tests, and then applies static analysis on the code and says, hey, here are the issues that we found, and prioritizes them, right? Prioritizes them so you see, hey, you know, these are just minor issues like you have an import statement that you're not using, you're importing code that you're not using, or you have an empty if block. Okay, you know, something to clean up, but not a high priority one, versus something that is, oh my gosh, you have something that is deadly, get rid of this right now, right? And so that way, as a team, we can see issues in our code in a prioritized way that a software tool has done, which is non-judgmental, and which will always, when it sees the same issue, will always prioritize it the same way, right? It isn't subjective, it's objective. It gives an objective assessment of our issues every single time, right? That way the team gets informed of new issues. You can set up these continuous integration servers so that anytime the static analysis tools finds a new issue, meaning an issue that wasn't there before, the developer who checked it in gets an email right away, or any sort of notification, maybe by instant messenger, gets notified, hey, that piece of code you checked in, guess what? It has a security vulnerability, or it's not as performant, or there's a better way to do it. I don't know about you, but I would love getting an expert reviewer to look at my code every single time and letting me know within minutes of a check-in, rather than finding a bug in my code 6 months from now, right? That's what we're talking about here. And the metrics, right? We talked about these issues being prioritized, being listed. It can be captured and displayed and graphed over time. And I'll show you some graphs. I apologize for my canned demos. It's graphing the same thing, so the graphs don't move, the charts don't move, but you'll have to imagine in your head that the charts can actually move over time, and so you can see the issues going over time. Why is that important? Well, because if you've ever been around managers, a lot of them tend to be very numbers focused, right? Why? Because there's a fundamental hallmark in management. They love to say this: if it can't be measured, it can't be managed. Why is that important? Because if somebody came to your manager's boss came up to him or her and said, what's the quality of your code? Your manager can say, it's pretty good. Or your manager could say, well, our analysis tools identified 732 high priority issues that we were able to reduce to 453. That's what my manager was able to do. And you can be darn sure that he really, really liked being able to say that. Because now you have measurable results. You're accountable as a team for your code quality, and you can demonstrate at the end of your performance quarter or year or whatever it is to your management chain, this is the value that I created for the team. These were the issues identified by an objective piece of software, not anybody's subjective opinions of code quality, but objective software identified these issues, and over this period of time, I was able to improve the software by reducing these high priority issues, medium priority issues, low priority issues, right? It helps you as a developer grow your career. It helps the team overall get more education and build itself into a learning experience. So again, as I said, the best thing in the world would be a team of absolute experts reviewing every single piece of code. We don't have that. This is the next best thing, right? And remember, to reiterate, machine time gets cheaper. So even though I said you may have to cut down on some of these analyzers, you may have to cut down on doing it, build every check-in, over time, machine time gets cheaper. So hopefully, you will be able to put this into practice. Maybe not now, but maybe you can convince your management team to buy you a server or to rent space on the cloud, maybe next quarter, or so on, so that hopefully you can put this into practice. All right, it's an acronym. There's more than one way to do it. Hopefully I got that right. There's more than one way to do it. Okay, good. All right. So, caveat here. I'm not telling you this is the only way to do it, right? I'm not going to say you have to use these tools. These are the only tools and technologies to use. No, no, no. There are many. Let's get that straight. Many, many tools are available, right? I'm only going to talk about the ones that I personally used and that I personally implemented in many of my teams and that actually work. Now also, just for the sake of time, I'm not going to go in depth into configuration specifics. I can answer, I can try to address some of them, but we'll go into a little bit, we'll go into a little bit of what these tools are, but we won't go into how exactly we configure them in Gradle or Ant or Maven or something, right? We'll go into a little bit, but not, in great detail. I'm always available afterwards if you want to go into specifics. All right, these are some tools that I would suggest you try. Again, just suggestions. I'm not saying these are the only tools or the perfect things in the world to try, but just some things that I've had success with, right? I've used Maven as our build system, right? Who's using Ant here? Who's still using Ant? Okay, one person. Who's using Maven 2? Maven 2? Maven 3? Maven 3, okay. Anybody using Gradle? Gradle, okay. All right. Okay, so I've primarily used Maven 2 and Maven 3 for my projects, and so what I'll be showing you is a Maven implementation of this. The concepts, though, are the same, right? You get it to work here, you can figure out how to do it in whatever build system you're using. I know even in the Windows world, there's a Windows way to do it, but again, we're the Java users group, right? So we're going to talk about just Java there. And in terms of continuous integration servers, anybody using Jenkins already? Okay, good. Good quarter of us, right? Anybody using, say, cruise control? No? Okay. Anybody using Go? Team City? Team City. Okay. Bamboo. All right. Anybody using Bamboo? All right. Okay. Great. The rest of you, are you using something else or not at all using any CI servers? Any others? No? Okay. So it seems like those are the most popular ones. So again, I'm just going to cover Jenkins. If you're curious, Jenkins is a CI server that has by far the most market share and by far the most mind share. So why I use it is because all software has bugs, all software has vulnerabilities. The more a piece of software is used, the more likely it is that a bug is going to be fixed. The more likely it is that someone else is going to find the issue and fix the issue, or at least mention it on Stack Overflow, and somebody else is going to chime in with a suggested workaround, right? Not telling you you have to use it. Again, these are just some things you might want to try. Jenkins, just a brief background on it. The inventor of Jenkins, a nice fellow who worked at Sun called Kosuke Kawaguchi, with Japanese ancestry. He wanted to come up with something, a code butler, is what he's talked about in his talk. And he was thinking, he's Japanese, he's like, well, butler, they're probably British. What's a good British name? And he's like, Hudson. Hudson's a great British name. So it was originally called Hudson. And then Sun was bought by Oracle, and he wanted to, spin off, there was a great brain drain when Sun bought Oracle. He and a bunch of other luminaries from Sun left. And he wanted to call it, continue calling it Hudson as he forked it and created the open source version of Hudson. But Oracle said, no, we own the trademarks, we own all the intellectual property of Sun, including all the trademarks. You can't call it Hudson, you have to give it some other name. So again, this nice Japanese guy, Kosuke Kawauchi, was like, all right, what can I do? What's another name? What's another British name? Jenkins. So he named it Jenkins because that's, to his mind, another Japanese name for a butler. So that's Jenkins. And then we're talking about static analyzers, right? So static analyzers, FindBugs was created at the University of Maryland, I believe, and it is a really nice static analyzer. PMD is another static analyzer. I like using them both because each of them has different strengths, and so by using both of them, if an issue isn't found by one, there's a greater chance it's found by the other, so you have a little bit better coverage. By the way, nobody remembers what PMD stood for. It originally stood for something, but not even the developers remember what it stood for anymore. CPD, copy-paste detector, is a tool that comes with PMD. Copy-paste detector looks for tokens. It says, hey, this chunk of code that I saw in this class file, I also saw it in this class file, and it shows you that. Isn't that great? That's an opportunity for refactoring. Either consolidate it into one superclass method or put it as a utility method that both of them call, right? So then you get code reuse, less need to update both places if you have a weakness in the code or vulnerability, right? So it identifies those. Cobertura is a Spanish-Portuguese word for coverage. It is a code coverage tool. Anybody use a code coverage tool? Okay, great. So about a third of you use code coverage tools. Code coverage tools track how much of our code is covered by our unit tests. Why is that important? Because imagine if we write a class file and it has a bunch of branching logic. If X, do this. If Y, do this, right? And we write a unit test, and our unit test only goes through the X condition. It doesn't go through the Y condition. Well, that's great. We think we've tested this class, but in reality, we've only tested one condition. Code coverage tools show us how much of our code, percentage of our classes, and even show us the lines, like in graphical way. It shows you these lines are green, meaning you have a test that covers it. These lines are red, meaning none of your tests cover it. And that helps you understand, oh, these are weaknesses in my unit test. These are things I need to code on, right? And then check style, as the name implies, it just checks for Java style conventions, and you can define your own. It comes with its own, but you can define your own if you want it for your project team. Like, do you want it indented with 4 spaces? Do you want braces on the same line versus on the next line, right? Check style can identify issues so that ideally you have code that is similar. Why is that important? Because you don't want false diffs, right? If one person indents 4 spaces and another person indents 3 spaces, you don't want that to show up as a diff because somebody checked in, right? You ideally want to show a diff based on functionality changes as opposed to stylistic changes. Check style helps you achieve a common look and feel. And lastly, open tasks. As the name implies, it's an analyzer that looks through your code for any tokens that you suggest, such as to do, fix me, right? Anything else you want to say, and it flags it and it lists it so that you can see it. It's like, oh yeah, here's a to-do that I wrote in my code 5 months ago. I forgot to do that. All right, there it is. I'll make sure to fix that. So again, it tracks these over time. So if a new to-do is there, the team knows, right? Ideally, you're not creating more to-dos. Ideally, you're reducing to-dos over time. So these are just some tools to try. Not saying that these are the perfect tools or the only tools. There are tons of others, but just the tools that I've had experience with that seem to really work. Now, in terms of time, it's 7:50. Do we want to do a break? Or?
Is it good?
It's a great, yeah, great.
Let's break now, take 10 minutes, and we'll regroup at 8 o'clock.
All right, perfect.
Cool.
Thanks, everybody.